Hey everyone, welcome back friends. Today we're diving into one of the coolest and most powerful ideas in all of mathematics, the derivative. Don't worry if it sounds a little scary right now. By the end of this lesson, you'll see it's actually super useful and not as hard as it seems. Let's go step by step, just like we're chatting together. Imagine you're riding a motorbike down the road. Sometimes you cruise at a steady 40 kilometers per hour. Speed stays the same. Other times you twist the throttle hard, speed shoots up fast, and when you slam the brakes, speed drops quickly. Now here's the big question. At any exact moment, exactly how fast is your speed changing right then? That how fast is it changing right now is exactly what a derivative tells us. In math language, the derivative of a function y equals f of x at a point x naught is the instantaneous rate of change of y at that exact point. It also has a beautiful geometric meaning. The derivative at a point is simply the slope of the tangent line to the graph of the function at that point. Think about it. The tangent line touches the curve at just one spot and shows you the direction the curve is heading right there. Now let's look at the official definition. Don't panic, it's simpler than it looks. The derivative of f at x naught is the limit as delta x approaches 0 of f of x naught plus delta x minus f of x naught, all divided by delta x. What does that really mean? We take 2 points very, very close together on the graph, find the average rate of change, the slope of the secant line, then make those 2 points so close they basically become 1, and that slope becomes the instantaneous slope. That's your derivative. All right, time for the tools you'll use all the time. These are your must-know basic derivative rules. Write them down and memorize them. They're like your superhero powers. First, if y equals a constant number, y prime equals 0. Easy. Second, if y equals x raised to the power n, y prime equals n times x to the power n minus 1. Third, constant multiple rule, y equals k times u of x, y prime equals k times u prime of x. Fourth, sum or difference, y equals u of x plus or minus v of x, y prime equals u prime plus or minus v prime. Fifth, product rule, y equals u of x times v of x, y prime equals u prime v plus u v prime. Sixth, quotient rule, y equals u of x divided by v of x, y prime equals u prime v minus u v prime all over v squared. Here are some super common ones you'll see everywhere. Y equals sine x, derivative is cos x. Y equals cos x, derivative is minus sine x. Y equals tan x, derivative is 1 over cos squared x. Y equals e to the x, derivative is e to the x. Y equals ln x, derivative is 1 over x. Y equals square root of x, derivative is 1 over 2 times square root of x. Let's try a few quick examples together. Example 1. Y equals 3x to the fourth minus 5x squared plus 7x minus 2. First, we apply the derivative to each term separately. So we have the derivative of 3x squared minus the derivative of 5x squared plus the derivative of 7x minus the derivative of 2. Now let's use the power rule for each term. We get y prime equals 12x squared minus 10x plus 7. Example 2. This time we're using the product rule. We have y equals the quantity 2x plus 1 times the quantity x squared minus 3. Whenever you see two functions multiplied together, think product rule. Let's identify our u and v. Let u equal 2x plus 1 and v equal x squared minus 3. Now find their derivatives. U prime is simply 2 and v prime is 2x. Easy. The product rule says y prime equals u prime times v plus u times v prime. Let's write that out. That's 2 times the quantity x squared minus 3. Plus the quantity 2x plus 1 times 2x. Now let's expand both parts. 2 times x squared minus 3 gives us 2x squared minus 6. And 2x plus 1 times 2x gives us 4x squared plus 2x. Put it all together. 2x squared minus 6 plus 4x squared plus 2x. Combine like terms and we get 6x squared plus 2x minus 6. Example 3. Y equals sine of 3x squared plus 1. Chain rule time, derivative of outside is cos of the inside times derivative of inside, which is 6x. So y prime equals 6x cos of 3x squared plus 1. Example 4, y equals square root of 4x minus 1. Rewrite it as 4x minus 1 to the power of 1/2. Power rule plus chain, 1/2 times 4x minus 1 to the power of negative 1/2 times 4. That simplifies to 2 over square root of 4x minus 1. Derivatives help us find instantaneous velocity and acceleration, locate maximum and minimum points like highest profit or lowest cost, write equations of tangent lines, model population growth, temperature changes, stock prices, basically anything that changes. You've got this. If anything's still confusing, drop a question. I'm here for you. Keep going. You're doing great.